Now in this lesson, we are going to learn radioactive decay law. Radioactivity is a random statistical process. Each decay is an independent event and one cannot tell when a particular nucleus will decay. Suppose we have got a 1 milligram sample of uranium 238. This has got 2.5 into 10 to the power 18 atoms. So many atoms are there in this 1 milligram sample. Out of so many atoms, 12 nuclei will decay in the next second. It can be 12, 11, 13, that's okay. But approximately 12 nuclei will decay in the next second. And they'll transform to thorium 234. Now you cannot tell which 12 nuclei will decay. But because of so many large number of nuclei present, 12 nuclei will decay in the next second. This is the power of nature, law of nature, right? Now, for large number of nuclei, the rate of decay, which is minus dn dt, is proportional to number of nuclei. Right? Now, we can put a constant there that is known as decay constant. So, minus dn dt is lambda n. Lambda is called decay constant or disintegration constant. Now, we can integrate this. We can write this as dn by n equal to minus lambda dt. Right? Now, integrate both sides. Integral of dn by n equal to minus lambda integral of dt. Initially say n naught nuclei are there. At final time when you are looking at the sample, n nuclei are there. Time is varying from 0 to t. This integration is very easy. How much is that? ln n. Then you put the upper limit, minus sign, put the lower limit. So what will you get? ln n by n naught equal to minus lambda t. Right? Now, this can also be written as n equal to n naught e to the power minus lambda t. Simple maths. This by this will be e to the power minus lambda t. Therefore, n is n naught e to the power minus lambda t. This is radioactive decay law. The number of nuclei will decay exponentially. If you make a graph, n on the y-axis, time on the x-axis, at the initial time the number is n naught, then it falls off exponentially. At infinite time it will become 0. This is radioactive decay law. At some point of time, the number of nuclei becomes half. Right? It will become n naught by 2. Then that time is called t half, half-life. The time at which the number of nuclei becomes n naught by e, that is known as average life. Remember, average life is more than half-life. So let's try to understand half-life. Half-life means what? When the number is becoming n naught by 2, then t is t half. When n is n naught by 2, the time is called t half. So put it in this equation. N naught by 2 is equal to n naught e to the power minus lambda t half, right? N naught and n naught will cancel. Take ln of both sides. So what will you get? Ln half equal to ln e to the power minus lambda t half. Ln half is ln 1 minus ln 2. So ln 1 is 0. So we get minus ln 2 equal to, this will come to the forward, minus lambda t half, and ln of e is 1. So we need not write that. So from here we get t half is ln 2 by lambda. This is again a very important relationship. T half is ln 2 by lambda. Same way, we can look at average life. When n is equal to n naught by e, then t is t average, the average life. Therefore, using the same equation, n naught by e is n naught e to the power minus lambda t average, right? Now again n naught cancels. You take ln of both sides. So you get this kind of equation. And then finally you get ln e, which is 1, equal to minus lambda t average ln e. So now we get t average, this is minus ln e. So t average becomes 1 by lambda. This is called average life or mean life. So important to remember, average life is more than half life. T average is 1.44 times T half. Very easy to check that. And T half is 0.693 times T average. ln of 2 is 0.693. So in this lesson, we have learned radioactive decay law. We started from the fact that the rate of decay is proportional to number of nuclei. So minus dn dt equal to lambda n. And then we integrated that and got this very important equation, n equal to n naught e to the power minus lambda t. And then we got this graph, the exponential decaying graph, which will meet the x-axis only at infinity. Initially there are n naught number of nuclei. The time at which the number of nuclei becomes half, that is known as half-life. The time at which the number of nuclei becomes n naught by e, that is known as average life. Average life is more than half-life. Average life is 1.44 times half-life. And half-life is 0.693 times average life. Half-life is 0.693 by lambda, that is ln 2 by lambda, ln 2 by lambda, and average life is 1 by lambda.